Hi, I'm Teacher Daisy. Now, let's learn Form 2 Chapter 2 Factorization and Algebraic Fractions. In this chapter, you will learn 2.1 Expansion, 2.2 Factorization, 2.3 Algebraic Expressions and Basic Arithmetic Operations. First, let's us understand what is an algebraic expressions. An algebraic expression is the combination of numbers and variables, using mathematical operations like addition, subtraction, etc. Example, 2x plus 4y minus 9 is an algebraic expression. Parts of an expression, variable. A variable is a letter or symbol that represents an unknown value, in this example is x and y. Constant. A constant has a fixed value. Any number without a variable is a constant. In this example is -9. Coefficients. The numerical factor of the term is called the numerical coefficient of the term. A coefficient is the number multiplied by the variable in an algebraic expression. In this example, the coefficient of x is 2, and the coefficient of y is 4. Terms. The parts of expressions, which we separate using operations, are called terms. In this example, the terms in the example are 2x, 4y, and -9. Factors of a term. Every term is the product of its factors. Factors, quantities being multiplied. Products, the result of multiplying factors. Let us move on to 2.1 Expansion. Expansion of algebraic expressions. Expansion of algebraic expression is the product of multiplication of one or two expressions in brackets. Expansion on two algebraic expressions. Expand expressions with single set of bracket. Every term within the bracket needs to be multiplied with a term outside the bracket. Distributive law. Example A. 8x plus 3 equals 8 times x, plus 8 times 3, equals 8x, plus 24. Example B. 2x, 5x minus 7, equals 2x times 5x, plus 2x times -7, equals 10x squared, minus 14x. Example C. -3, x squared plus 4x minus 2, equals -3 times x squared, plus -3 times 4x, plus -3 times -2, equals -3x squared, minus 12x, plus 6. Exercise, expand the following expressions. The answer is as follows. Expand expressions with two sets of bracket. Every term in the first bracket must be multiplied with every term in the second bracket. Example: a plus 2, a plus 1, equals 8 times a plus 1, plus 2 times a plus 1, equals a squared, plus a, plus 2a, plus 2. The like terms a plus 2a, can be solved. Equals a squared plus 3a plus 2. Exercise, expand the following expressions. The answer is as follows. Combined operations including expansion. Combined operations for algebraic terms must be solved by following the Bodmer's rule. Bodmer's rule means the priority of solving the calculation is as follow: firstly bracket, secondly order, thirdly division, fourthly multiplication, fifthly addition, and lastly subtraction. Exercise, simplify. The answer is as follows. Solving problems. Example, Juan Maria has a piece of carpet, 3r minus 2 meter in length, and r plus 1 meter in width. Calculate the area of her carpet. Solution, let us draw and visualize the carpet. Area equals length times width, equals 3r minus 2 times r plus 1, equals 3r squared, plus 3r, minus 2r, minus 2, equals 3r squared, plus r minus 2. Hence, the size of the carpet is 3r squared plus r minus 2 square meters. 2.2 Factorization. Factors and factorization concept. Factorization is the process of determining the or algebraic terms, and when multiplied together will give the original expression. Factorization is the reverse process of an expansion. Example, find the factors of 3p. 3p equals 1 times 3p, equals 3 times p, therefore, the factors of 3p are 1, 3, p, and 3p. Common factor, the factor of two or more numbers. 1 is the common factor for all algebraic terms. Example, find the common factor of 12 and 30. Factors of 12 are 1, 2, 3, 4, 6 and 12. Factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. So, the common factors of 12 and 30 are 1, 2, 3 and 6. Highest common factor, HCF, is the largest of those common factors. Exercise, list out all the common factors for each of the following terms. Solution. A. The common factors for 6h and 4gh are 1, 2h, and 2h. B. The common factors for 9c squared d, 3d squared d and 6def are 1, 3d, and 3d. 3d is a common factor, as it can divide all the above terms exactly. Factorization of algebraic expressions. Method 1, using HCF. Finding the HCF for 8x and 12x squared. 8x and 12x squared can be divided by 4, equals 2x and 3x squared. 2x and 3x squared can be further divided by x, equals 2 and 3x. Therefore, the HCF for 8x and 12x squared is 4 times x, 4x. Exercise 1. Determine the highest common factor, HCF, for each of the following terms. The answer is as follows. Two. Factorize the expression below. The answer is as follows. Method 2, using difference of squares of two terms. This method can only be used if the two algebraic terms are perfect squares. Example, factorize 4x squared minus 9. 4x squared minus 9 equals 2x squared minus 3 squared equals 2x plus 3 times 2x minus 3. Note that a squared minus b squared equals a plus b times a minus b. A squared plus 2ab plus b squared equals a plus b times a plus b. A squared minus 2ab plus b squared equals a minus b times a minus b. Exercise. Factorize each of the following expressions. The answer is as follows. Method 3, using cross multiplication. Example, find the factor of x squared plus 6x plus 8. Step 1, compare the coefficients with the x squared plus bx plus c. Hence, a equals 1, b equals 6 and c equals 8. Step 2, factors of 8 are 1, 2, 4 and 8. 2 and 4 are selected because they conform to C. That is, 2 times 4 equals 8. Step 3, 2 and 4 are chosen because they conform to B, that is, 2 plus 4 equals 6. Step 4, do cross multiplication, as shown below. Step 5, factors for x squared plus 6x plus 8 are x plus 2 and x plus 4. Exercise. Factorize each of the following expressions. The answer is as follows. Factorize the following expressions. 2m squared plus 7m plus 6. Multiplication of factors of 6. 1 times 6, 2 times 3. First trial. Incorrect. Second trial. Correct. Hence, 2m squared plus 7m plus 6 equals 2m plus 3m plus 2. Exercise. Factorize each of the following expressions. The answer is as follows. Factorize each of the following terms. A. PQ plus QR plus PS plus RS. Group terms with common factors in a bracket. Equals PQ plus QR plus PS plus RS. Take out the common factors. Equals Q times P plus R plus S times P plus R. Equals Q plus S times P plus R. B. 2px plus 6qy minus 4py minus 3qx. Group terms with common factors in a bracket. Equals 2px minus 4py minus 3qx minus 6qy. Take out the common factors. Equals 2p times x minus 2y minus 3q times x minus 2y equals 2p minus 3q times x minus 2y. 2.3 Algebraic expressions and basic arithmetic operations. In this section, we will learn the addition and subtraction of algebraic expressions with same denominators and different denominators. Let's learn the addition and subtraction of algebraic expression with same denominators. Example: simplify each of the following. A 4a over 5 plus 3a over 5. Since the denominators are the same, so just need to add the numerators. Equals 4a plus 3a over 5 equals 7a over 5.
B. Y over 2x minus 3y over 2x. Since the denominators are the same, so just need to minus the numerators. Equals y minus 3y over 2x equals negative 2y over 2x. Simplify the fraction. 2 can be divided by 2. Negative sign is usually not attached to the denominator. Equals negative y over x.
C. X plus 2 over 5w minus x minus 5 over 5w. Since the denominators are the same, so just need to do the calculation of the numerators. Equals x plus 2 minus open parentheses x minus 5 close parentheses over 5w equals x plus 2 minus x plus 5 over 5w equals 7 over 5w. Exercise. The answer is as follows. Addition or subtraction of algebraic fractions with different denominators. One of the denominators is a multiple of the other denominators. Example: simplify the following expressions. A. 3 over 4y minus 1 over 2y. Equating the denominators to 4y, so 2y times 2, and 1 also need to times 2. Equals 3 over 4y minus 2 over 4y. Equals 3 minus 2 over 4y. Equals 1 over 4y. B. 4 over rs minus 2r over s. Equating the denominators to rs. So s times r, and 2r also need to times r. Equals 4 over rs, minus 2r squared over rs. Equals 4 minus 2r squared, over rs. C. 1 over 4p plus 4 over 6p. First, let us find the LCM for 4p and 6p. 4p and 6p have the common factor, which is 2p. So 4p divided by 2p is 2. And 6p divided by 2p is 3. 2 and 3 do not have common factor. Therefore, the LCM equals 2p times 2 times 3 equals 12p.
So now we know that 4p and 6p, LCM, 12p. In order to make the denominator become 12p, 1 over 4p, need to times 3, for both denominator and numerator, and 4 over 6p, need to times 2, for both denominator and numerator, equals 3 over 12p plus 8 over 12p, equals 3 plus 8 over 12p, equals 11 over 12p.
D, m over 4r, minus 5m over 14rs. Let us find the LCM first. 4r and 14rs also can be divided by 2r. So 4r divided by 2r is 2. And 14rs divided by 2r is 3. 2 and 7s cannot be further divided already.
Therefore, the LCM equals 2r times 2 times 7s equals 28rs. So now we know that 4r and 14rs, LCM, 28rs. In order to make the denominators the same, 28rs, m over 4r times 7s for both denominator and numerator, 5m over 14rs times 2 for both denominator and numerator, equals 7ms over 28rs minus 10m over 28rs, equals 7ms minus 10m over 28rs. Addition or subtraction of algebraic fractions with different denominators. Denominators that are not common factors. Example: simplify each of the following expressions. A. 5x over 3 minus 3x over 2. First we must make the denominators to the same, which is multiply both the denominators, 3 times 2 and get 6. So, 5x over 3 times 2 for both denominator and numerator, and 3x over 2 times 3 for both denominator and numerator, equals 10x over 6, minus 9x over 6, equals 10x minus 9x over 6, equals x over 6. b 2a over 3 plus b over 2c. In order to make the denominators the same, 2a over 3 need to times 2c for both denominator and numerator, while b over 2c need to times 3 for both denominator and numerator, equals 4ac over 6c plus 3b over 6c, equals 4ac plus 3b over 6c. Multiplication and division of algebraic expressions. In this section, we will learn multiplying algebraic fractions and dividing algebraic fractions. Multiplying algebraic fraction. Example A squared minus 1 over 2ab times b squared over 1 plus a equals a plus 1 times a minus 1 over 2ab times b over 1 plus a equals b times a minus 1 over 2a. B h plus k squared over 2k minus h times 6k minus 3h over h squared minus k squared equals h plus k times h plus k over 2k minus h times 3 times 2k minus h over h plus k h minus k equals 3 times h plus k over h minus k. Note, you can only cancel off factors, the entire contents inside a bracket. You cannot cancel terms which is part of what is inside a bracket. Dividing algebraic fractions. To divide algebraic fractions, find the reciprocal or flip the second after the division sign and multiply the fractions. A over b divide by c over d equals a over b times d over c. Example: 2p plus 4 divide by p squared minus 4 can be written as 2p plus 4 over p squared minus 4 equals 2 times p plus 2 over p squared minus 2 squared equals 2 times p plus 2 over p plus 2 times p minus 2 equals 2 over p minus 2. Exercise: simplify. The answer is as follows. Combined operations of algebraic expressions. Exercise: solve the following using combined operations. The answer is as follows.
If you find this video helpful, don't forget to like, share and subscribe our channel. And if you got any question can comment below. Thanks for watching.